This patient is a high-resolution PET-CT coming from the United Imaging Total Body Scan, the uExplorer. So again, technology that is quite recent. We were able to add it to our portfolio of data that can be open and handled by our multimodality viewer, as you can see here. Again, we're looking at a different layout than before. So layouts, as usual, with any Hermes configuration, can be customized to your liking as part of any workflows. So in this case here, we're looking at fused TCS, just PET and MIP. And again, the overlay as well can be customized. As you can see here, part of the overlay that can be interacted with. For example, the fusion percentage. We can simply scroll the wheel of the mouse and change our fusion percentage. And I will show you the different steps and slabs in a few minutes. So here, what is very interesting on top of being able to show you very high quality images is the MIP itself is beautiful. If I go full screen here and I zoom even more, so again, I can use keyboard shortcuts, in this case, Control and left mouse click, and I can zoom. Here I can zoom even more to really show you the high quality. There's no pixelization, there's no line, there's no diamond shape artifact that is very typical of a trilinear interpolation, which is what you would find in most viewers. We've gone a different way. We've gone completely 3D with a tricubic interpolation, which is why you don't see any artifacts and why you see this amazing quality for the MIP. Our viewer is also a full 3D viewer, which means that you're never looking at a 2D image. You're always looking at a 3D rendering of the study. So again, if I use this cube in the bottom right, I can change the angle and I can look whichever way I want at my image. To show you what the interpolation does, if I zoom even more here and I remove the interpolation, this is the raw image. This is what we get from the vendors, from the acquisition station. So it is looks quite pixelated, but with our tricubic interpolation, then it becomes this nice, crisp, very smooth image. And that is how we can create superior image quality versus other viewers using the same data set. If I go to a different TCS display here and I drag and drop my CT and my PET to the image. So here again, it looks like we're looking at 2D images because we're looking at slices, but really it's a true 3D representation of the data set. We have a plane basically cutting through a 3D image. So the best way to show you that is indeed a 3D image is again the ability to reorient the patient data set into any plane that we want, in this case using the rotation cube. So again, the interpolation is recalculated every time we change the orientation, so that even if I'm not in the traditional orthogonal plane, and if I zoom in, I'm not losing any quality on my image. It is always a proper, tricubic interpolation and giving us the maximum quality for viewing this image. Same thing, this allows me to go into slab mode, and I can decide to look at my study not just slice by slice like it is by default, but I could say show me slabs of 10 millimeters, And now you can see that every time I'm looking at this study here, the coronal view, and I scroll through, I'm scrolling through 10 millimeters. And again, the quality is perfect. And again, here we're looking at mean. We could change that to a maximum intensity projection, or we could switch it to a minimum intensity projection, which you've seen the change here at the bottom. I go back to mean. We're looking at the same 10 millimeter, but the effect is different. But this is only possible because we have a true 3D viewer, and this is how we get this high quality rendering for our images.